I think we should get started or we'll run out of time, and I'm very keen for us to not do that. So if you've just joined, there's some technical information on the screen in front of you. Please send any technical questions that you've got to in the Zoom chat to Angel, whose name is in Zoom chat Mem AV Tech, and as I've been saying, we'll use Slido for questions. So let's begin properly. So I've already introduced myself. I'm Helen Cleugh. I'm the Vice Chair of WCRP's Joint Scientific Committee, and it's a delight to have you here today. But I'm actually going to hand over to the Chair, Professor Detlef Stammer, to say a few words of welcome as well. So Detlef, over to you.
Thank you very much, Helen, and also a very warm welcome from my side to this climate research forum in the region that is North America, that is Mexico, that is Greenland, and Helen will actually give more details to this. There's this regional forum, or the idea of this really came out of our reorganization discussion within the World Climate Research Program, WCRP. And the original idea was, in fact, to get input from the community into our thinking and our planning. But we have extended this, in fact, also to, well, to hear from you, but also to inform and train communities. And so this is one of the several regional forums that Helen and her team is organizing, and I'm really delighted to see so many online. I'm really looking very much forward for the next 2.5 hours to hear you, to get your input, to hear your questions, but also to see your interest in WCRP, and maybe later on to see you, in fact, in the activity of WCRP on the long run. And maybe I stop here, Helen, and turn over back to you for, well, maybe more information and then into the next session.
Thank you, Detlef. And I just wanted to add a couple of words around the purpose of these forums. It's as Detlef said, we're really keen to strengthen our connection with our research community around the world, and provide a platform, if you like, or a forum, so that we can both share information with you, but as we move forward, also encourage discussion. And then the last thing I just wanted to say is that these forums are intended to complement and build on and support our ongoing work in the WCRP across all of our core research activities. And you'll hear more about these core research activities in session 2. So whilst these forums might be new, they are intended as another way of strengthening the ongoing work that we do. Before I get into the presentation proper, I really want to thank some people. Our focal points for the region, these are all people involved in the WCRP who were nominated to help organise today's session. They come from across the region. I won't read their names out, but I do want to thank them all for helping organise today. WCRP has a series of international project offices. GWEX and Cleugh are the international project offices that have supported preparing for and running today's forum, so a big thank you to them for doing that. And we've also been fortunate in that the US Global Change Research Program and National Science Foundation have also provided support for today's forum, and we thank them as well for that support. I'm going to hand over to one of our regional focal points, Tim Schneider, to give us an introduction to Slido and ask some icebreaker questions just to get you used to using Slido. So Tim, I'm just lining you up to get ready, but before I do hand over to Tim, I just wanted to provide the slide. It's very busy, I know, but it gives you a roadmap for today. We will try and finish on time, so I'll be keeping a close eye on timing. We're in the introduction session at the moment. Once we've finished the Slido introduction, we'll go straight to a presentation from Detlef and I about the WCRP. It's intended to provide information about the WCRP, and then we'll have a break for some questions, and we'll ask you some questions. Then we'll go into a session of 3 invited speakers from our WCRP community, followed by some more questions using Slido, and then we go into a panel discussion with 4 short interventions from the people that you can see listed there, and there's opportunity there for feedback and interaction with those speakers and with us more broadly, and then we'll wrap up in session 5. So that's the plan for today, and I will now hand over to Tim to talk to us about Slido. And Tim, if you'd like me to stop sharing, just let me know at any point. Over to you, Tim.
Oh, great. Thank you, Helen. Yeah, so Tim Schneider here. I'm with the National Center for Atmospheric Research in Boulder in my day job. This is actually my first sort of formal contribution or interaction with WCRP, and I highly recommend it. They're wonderful people. It's been a great experience for me. So I'm glad you're here and getting engaged. So we're going to use, as Helen has said a couple of times, Zoom is a great place, or the chat function in Zoom is a great place for you to kind of chit chat amongst each other and for general banter. But because we have so many people and our time is tight, we're going to use Slido as a means to interact with you. So it's just not all projection. And we're also going to use it as an opportunity to ask questions from the different speakers and panelists coming up. So there's kind of 2 modes. There's the poll and the survey mode, which we'll have a chance to try in just a second. And then there's a question and answer mode. And in the question and answer mode, it's really important because there's so many people and so little time, we can't answer all the questions. If you see a question you really like, just upvote it. And when we get to the question and answer part of the panel or the session, my colleague Amy Butler and I will help route those questions to the speakers. So please, vote if you see questions that are important to you, and ask your questions even if they don't get voted, because we'll definitely record them and try to capture them and respond in some fashion. So that's important. I guess the last point is, why don't everybody jump over to the Slido in a browser window. There's a link in the chat right at the moment. You could click on that. It was also in your invitation. I see there's 81 people over there now. We have a couple of icebreaker questions just to get you familiar with it. They're quick and easy. And so I'm going to fill mine out. The first question is, what city and state, if that applies to you, and country are you joining from? This will just help us to kind of get to know where we're all coming from and how well we're doing representing the region. And that's just a little field in which you type in. And then the second question we have for you in our icebreaker is, have you heard of the World Climate Research Program before? So you can say yes, no, or maybe. It's a button you can click. And while you're over there, and I see somebody's already jumped in the aqua colored bar across the top of the browser window in Slido, you'll see that right in the middle, there's a Q&A and there's a polls, and it should have dropped you into the polls function. But if you want to ask a question for a speaker, and there's already one question there, you just click on the Q&A and it'll take you to a different screen. And someone was testing it, so we got it, and there's 14 upvotes, so that's great. So I think, I'm not sure how to tell how many responses are coming into the polls, but Helen, if we want to pull that up.
Yep. So I think we're going to have Narelle. So Narelle, do you need me to stop sharing?
Yes, please.
And I should say to the audience, while Narelle's bringing that up, is that this is all of you, all 170 of you that are here today are a little bit of a test case for us. We've not used Slido in these forums before, so you're helping us learn how to do this better. So thank you for that. So there we go. There's the word cloud with the numbers of people across the region. So that's interesting. We've even got some people from further outside of the region, like me from Australia, except I didn't fill in the poll, people from Europe, but certainly clustered around the US, Canada, Jamaica. That's great. So Tim, did you want to add anything more, or Narelle, to this part?
I don't know if we want to look quickly at the next question on the screen maybe, yep. But otherwise, Helen, I think.
Here we go. Oh, that's a relief. 81% of you have heard of us. And 6% maybe.
So yeah, let me just maybe reiterate one point. So as we go through our speakers, if you do have questions, please put them in the Q&A in the Slido, and we'll monitor them, and then we'll route the top questions that we have time for back to the speakers. And I think that's it, Helen.
Great, thank you. Then I'll ask Narelle to stop sharing her screen, and I'll bring mine back up. Okay. So I'm going to now, just to let you know, we're at 180 participants. I'm now going to go into session 2, which is our presentation on the World Climate Research Program. To keep things simple, you'll hear mostly my voice, but I will hand over to Detlef at a couple of points to add his perspective. We've learned from these virtual presentations that keeping it simple helps stop any risk of technical flaws coming in. So very briefly to open, the World Climate Research Program in 2019 launched its strategic plan for the coming decade. That kind of describes who we are, what do we do, why does that matter, why is it important, and what are our high-level goals. To implement the strategy, we're developing new science initiatives, we're refreshing and strengthening some of our core activities, and we're modernizing our structure. And the purpose of this talk is to describe this plan, some of the implementation activities, the structure and the timeline. It is quite high level, it doesn't go into a great deal of detail, but we do hope that it's a first step in what will be a broader dialogue. And to that end, we do encourage your questions and discussion, whether it's today or whether it's after today, because we want to hear about your needs and your priorities, because these can help shape our science planning. And we want to explore how we can better work together to achieve our vision for a world that uses sound and relevant and timely climate science for a more sustainable world. So this is interesting. There we go. Right. It's always a worry when you hit page down and nothing happens. So the World Climate Research Program, or WCRP, addresses frontier scientific questions related to the coupled climate system. I'm sure you're mostly aware of that. The point about the WCRP is that we're addressing questions that are too large or too complex to be tackled by any single nation or agency. These are questions that takes a world research program to do the research. This is because that science covers the whole, all of the domains of the Earth system across the oceans, the atmosphere, the cryosphere, the land, the way they interact, the way they feedback with human systems and natural ecosystems. It involves observations, analyses, simulations, process studies across all time and space scales. To do that requires deep coordination and collaboration around the world and across disciplines. And so that was what the WCRP was established to do, was to facilitate this coordination over 40 years ago. In the first 4 decades, much of the focus was on understanding and particularly on the predictability of the climate system, and especially on the effect that human activities were having on our climate. Looking to the future now, WCRP recognises the critical need for climate information for use in decision-making, managing climate risk, supporting climate adaptation and mitigation. And meeting that need will challenge our science and our community. It requires some new science. It requires new technologies and new ways of co-designing knowledge and information. It requires a worldwide coordinated effort, including stakeholder engagement and a prepared scientific workforce. And it requires strong global partnerships, because we can't do all of this on our own. So the new strategic plan, for the decade, addresses these challenges and opportunities for the coming decade. It articulates what our vision is and why that matters. It clarifies our purpose, which is about coordinating and facilitating international climate research. The strategic plan, if you're interested and haven't seen it, it's available online. You can see the URL there. And there's even a short video that you can see there that describes more about WCRP's history and our future strategy. For now, We'll just show this schematic from our strategic plan to briefly walk you through the key elements. The first is that we've identified 4 high-level scientific objectives. These are listed 1 to 4 on the right-hand side. You can read them there, but just to say, they go from the fundamental understanding of the climate system, that's processes, variability and changes, through to prediction of the near-term evolution, and thirdly, refining our ability to anticipate the longer term response and future trajectory of climate system change. And fourthly, to better integrate natural and social sciences so that we're building a bridge between climate science and societal needs. Of course, this occurs across a range of space and timescales. The arrow on the right-hand side depicts that. And achieving those objectives relies on understanding, observing, modelling and collaboration. These are at the very core of the WCRP, which is why they're in that inner circle. This depends critically on infrastructure, whether that's for our observations and modelling, but also for data sharing and data management to support communication and outreach. And if we're going to connect with the wider science community and stakeholders, we also need to build our partnerships, address capacity building and education needs. And throughout, our engagement and communication remain a priority. And it's one of the reasons that we're holding these forums. Since 2019, we've been very focused on the implementation of the strategy, especially to identify and prioritise the research that's needed for the decades ahead so we can achieve our outcomes. Some of this has involved developing a series of new activities that we've called Lighthouse activities, not only to support, but hopefully to accelerate some of the priority research that is needed. So just to talk about these lighthouses for a moment, they're designed to advance some of the new science and technologies, and even where appropriate, new institutional frameworks that are needed to better manage climate risk and meet society's need for robust and actionable climate information. These could be major experiments, high visibility projects, or even infrastructure building blocks. Importantly, they're intended to be quite ambitious, exciting, forward-looking, and very much externally or impact focused. They'll draw upon, importantly, all of WCRP's core scientific and technical capabilities and our strategic partnerships. The 5 Lighthouse activities that we've identified are shown here: My Climate Risk, Safe Landing Climates, Explaining and Predicting Earth System Change, Digital Earths, and WCRP Academy. Now, because these are new and still being developed, I'm going to actually go into a little bit of detail on each of them, and then at the end of that, I'll actually ask Detlef to add some comments. I should say right at the beginning that these Lighthouse activities are still very much being designed in terms of their specific science activities, their partnerships, etc. That's all in the development phase. But hopefully, this thumbnail sketch will give you a flavour of what in these Lighthouse activities. So the first, the WCRP Academy, is a cross-cutting Lighthouse activity. It addresses the training and education needs of our future climate scientists and maybe even users of climate science. It will do this by building what we call a marketplace for climate science training, where we bring together providers of that training. It will do an annual stock take to find out what's available and where are the gaps. And the Academy is very keen to involve more people. So if you're interested, there's 3 ways you can be involved. The stock take will be rolled out soon, so watch for that. And when we get the results in, if you're an organisation that actually undertakes training, then maybe you can help fill some of the gaps that we've been identified. We hope to have those results towards the end of this year. We're also keen to have extra people join our working groups. We're looking for people with expertise in working with philanthropic donors or setting up not-for-profit organisations. So if you're interested, please contact Narelle. Her email address is there, and she can put you in touch with the WCRP Academy. The second cross-cutting Lighthouse activity is the Digital Earths Lighthouse. And The summary there, the thumbnail sketch really describes, it's about developing a digital and dynamic representation of the Earth system, blending models and observations so that we can look at past, present, and possible futures of the Earth system. Just briefly, I wanted to highlight some of its key aspects. It's as much about developing a framework for these capabilities and the principles that underpin the development of software so that it is open and freely available, modular and interoperable, and built to agreed upon standards. We envisage that there'll be both global and regional digital Earths under this framework. And this Lighthouse envisages organizing itself into 4 components across science, technology, and user engagement. And the 4 components you can see there. So observations and data assimilation are key and critical to this Lighthouse, as will be a focus on fine-scale modeling and thinking about the technologies that are challenging the way we've been doing climate modeling for the last 40 years, and then how we engage with users. And one of our speakers in session 3 will talk a little bit more about digital Earths. The third, explaining and predicting Earth system change, is all about developing a capability to enable us to observe, explain, and provide early warnings and predictions of Earth system change. The cartoon headline for this one is "What on Earth is going on?" And this capability that we're building will have 5 elements to it. We're going from the inputs, which is our monitoring and our modeling of Earth system change that you can see there at the top of that schematic. The process understanding will come in from our other WCRP core projects. Then we have an activity around integrating that to do attribution, prediction, and projection, to deliver our outputs, which include assessment of current and future hazards and early warning of high impact events. And I'll just draw your attention to our announcement today for a workshop in September that is being run by this Lighthouse activity. Safe landing climates is about looking at longer term pathways for safe landing places. This is the analogy that the group thought about, the famous time that the plane landed on the Hudson. So safe landing places for human and natural systems over longer timescales, focusing mostly on the global scales. This is where we bring in our climate science and our social and economic science. This Lighthouse is still very much in its planning phase, but it envisages organising itself around these 5 topics. Definitions about how we define safe landing safe landings. That includes metrics for defining impacts, pathways that consider adaptation and resilience, as well as climate engineering options, and a framework to enable an open and iterative dialogue. Another activity around defining what are key tail risks. These include tipping points, but not just tipping points, and how might we mitigate or avoid them. And then 3 other project activities focusing on the important role that land plays in terms of climate mitigation, but also what impact does that have on land ecosystems, water availability, and safe levels of sea level rise. The My Climate Risk Lighthouse activity has the goal of really taking a new approach for assessing regional climate risk. This is an approach that starts with the decision context so that we can make climate information more meaningful and useful at local and regional scales. And the vision is not so much about new science around models or process studies, but rather how do we combine models, observations, and process studies together so that they can be useful in the context of uncertainty. It will do this by developing a risk framework that can be applied to various types of regions to underpin the development and delivery of climate services, using a case study approach via what we're calling labs, which are more like communities of practice than physical infrastructure labs, where this framework can be demonstrated and applied. So that was a quick tour through the lighthouses, and Detlef, I promised that I'd give you an opportunity to add some comments if you wanted to about the lighthouses.
Well, thank you, Helen. I think it was actually all very complete and very well expressed, and so there's not too much I can add, except that maybe a few points. First of all, the new WCRP is really designed because we do know that the kind of the situation we are all together in. And so in order to keep, for instance, with climate impacts, there is some urgency, and we have to deliver some questions very quick. And the Lighthouse subject and the prioritization really were born out of this urgency sense, where we really wanted to identify really the important aspect that needs to be dealt with in a quick way. And so the idea here was really to identify kind of big experiments, big steps, that if we provide answers, if we solve these problems, that we make real progress. And so this is the idea behind these Lighthouse activities. These are not just simple projects. They are really meant to be like a new toga or a new big experiment that we only can do internationally together. That's where the W from WCRP comes in. And so this addresses the urgency. The new WCRP also has partnerships very high up in our mind. And so all these Lighthouse activities and the topics can only be done in partnership. And this is within WCRP, and we have our community since a while. These Lighthouse activities are really meant to be integrating across WCRP and integrating the communities, bringing us together to provide quicker and better answers than we could do individually. And the third part in the new WCRP is flexibility. And so we have a beginning here. As Helen said, these are still under constructions, but they will actually remain under construction in the sense that dynamic development is built in right from the beginning, to always be up to date, to always actually address urgent aspects that came up or will come up. And so these three things together really form the new WCRP, urgency, partnerships, and flexibility. And they were really important to design the Lighthouse idea to bring this together. But keeping in mind, the Lighthouses are integrating, they are interdisciplinary, and they are big to really provide big answers. Helen, back to you.
Thank you, Detlef. And that's a nice segue to the slide that's been sitting there for a few minutes now. Just to say, where are we at? The plans for these are still under development, as we've both said. And we'll see the first version of these around June, and then our goal is for the rest of 2021 for ongoing consultation. As Detlef said, this is really important because we want to continue to talk with our community to enhance the diversity of the people that are both contributing to the research but also using it. We want to start co-designing some of the activities with our key partners, and as Detlef said, we need to ensure that they draw on WCRP's core research and remain flexible. And so this ongoing consultation is important for that. We're also seeking interest from potential funding partners as well. And if you're interested in knowing more about the Lighthouse activities, then in session 5, we can show you how you can connect with us. But in addition to the lighthouses, which we've focused on a little bit, it's really important that we say that we realize that we will continue to develop the science and technologies that are needed to advance our understanding of the Earth's climate system in a, if you like, in a more fundamental way, and to co-develop that climate information that we need, that we've talked about earlier. Now, that of course requires a very large range of skills and capabilities, which we've been fostering for the entire life for over 4 decades of WCRP. And these capabilities and the research communities that sit around them are the very foundation of the climate system science that's supported and coordinated by WCRP. Organisationally, they've existed through 4 core projects and a range of working groups, panels and advisory councils. The new WCRP, our new strategic plan, recognises the critical need of sustaining and nurturing these capabilities and these communities into the future. And this has required us to think about how we can strengthen these core capabilities, what needs to be prioritised, so that we can meet the current and future science questions and challenges that face us. It's also required us to think about our structure so that it is accessible and effective. And I just wanted, therefore, here and on the next slide to talk briefly about these underpinning core projects, because as I said, they are at the foundation of the World Climate Research Project. These 4 core projects, which have been through the life of the WCRP will remain going forward into the future. All of them are undergoing a little bit of an internal review about the scope of their science and governance and how they can better work together as well. They already do, and what they need to do in the future to make that even stronger. There is a lot of work being done in these 4 core projects. One slide cannot do justice. So I really encourage you, if you don't know about them, to go to and have a look and learn more about what they're doing. And they go across the 4 domains, if you like. So Cleugh, as you can see, focusing on climate and ocean variability. GWEX, looking at energy and water exchanges, particularly focusing on the land surface and its interaction with the atmosphere. Cleugh, looking at the interaction between the cryosphere and the global climate system. And then Spark, with its focus on the role of the atmosphere on climate variability and prediction. It's both the atmospheric dynamics, but also atmospheric chemistry. As I said, they will remain and provide a core foundation of WCRP's science going forward. But we also recognise, as part of the new WCRP, the need for 2 new core projects, and this is what they are. The first is on Earth system modelling and data, and particularly a focus on the fusion of models and data. And the second is on the provision, or the development actually, of the science and capability needed to provide information that is societally relevant. So WCRP, Regional Information for Societies, is the second new core project that we are currently designing. They will unite and strengthen ongoing work that we're already doing, as it says on the slide. So some of you might be familiar with our working groups on coupled modelling, which includes our CMIP work, for example. That will be included in the new core project on Earth system modelling and observational capabilities. Some of you will be familiar with Cordex, and that will be included within this new core project around regional information for societies. By defining them as core projects, we give them the opportunity to provide a very clear focus and vision for the future decades. And as I've said, they're under construction at the moment in terms of their science scope and governance. It also means that we're sunsetting our grand challenges, which some of you might be familiar with. By sunset, that means the science that still needs to continue, because not all the research has been done yet, will transition into our core projects or Lighthouse activities. But some of these grand challenges have achieved the objectives that they set out to achieve, and we'll be holding various forums over the next few years to acknowledge and celebrate the achievements of our grand challenges. So this is a structural diagram to show how all these elements fit together. This is a more simplified structure than what we've had at the past, so that it's more fit for purpose for supporting our strategy and delivering on our goals. I don't want to dwell on it. I'll just quickly highlight some of the key aspects. In the yellow at the bottom, as I've said, the foundation, the core of our research capability are our core projects, which I've just described in the previous 2 slides. At the top, overseeing, if you like, guiding the science of the WCRP is the Joint Scientific Committee. It's what Detlef and I are the chair and vice chair of. All of the WCRP is supported by a secretariat, primarily based in Geneva. And then we have our new Lighthouse activities, which we've already described. And our core projects and Lighthouse activities are supported by project officers. And we have ongoing activities as well that are sponsored and done by all of these core research activities. These include traditional fixed term projects, but also conferences and workshops, data sets, activities that for capacity building, rapid updates and so on. And these will continue into the future as well. And I just want to reiterate the point that Detlef made, that the Lighthouse activities are intended to be cross-cutting, drawing on those capabilities from our core projects. In terms of timing, this is what we call our soft transition. The soft transition really means that we're moving into the new structure of the WCRP while it's still being developed. So we've been doing a lot of consultation over the last year or 2, and we've identified these new core projects, new Lighthouse activities now, which are being designed. They've been approved to go forward. And through 2021, 22, we will have that new structure in place, supported by an implementation plan that will be a dynamic, flexible document, and all with the goal of launching the fully fledged WCRP in early 2023 at our second Open Science Conference. And just a shout out here to that conference, the first circular was distributed a few weeks ago. So this is where we are in a timeline sense. And again, Detlef, over to you if there's anything that you'd like to add.
Well, Helen, this was actually very complete, and I do not have to add, well, nothing or not much. The only thing I really want to stress again, first of all, the core projects over the years had become brands. I mean, basically everybody knows GWEX, everybody knows Cleugh, in particular the North Americas. And of course, that work we do not want to interrupt. These are really functioning groups, functioning communities, and they will keep working. And the other thing I want to highlight again that in fact, we have made the transition. This soft transition is taking place as we speak. And so we are already living in a world that has a new structure and not the old structure anymore. And that means we start to think about this and start to talk about the new science plans and start to move forward, which of course creates a lot of excitement in the communities. It is already the new WCRP, and we are really looking forward to also celebrate the success of the old, but also the way forward with the new WCRP. And again, this is a wonderful moment for the next generation to actually come in, because there's a huge amount of work ahead of us, and we need the next generation to come in to accomplish it. Thank you, Helen.
Thanks, Detlef. And that's a lovely segue to my final slide for this session. And again, Detlef, if you want to add something at the end of this, I'll welcome that too. I just really, or we both actually want to really reiterate this point about collaboration and partnerships. We're keen to work with all of our co-sponsors and partners and support our national agencies towards our goal of ensuring that we all have the climate knowledge and information that's needed, and to ensure that it's accessible and relevant. As Detlef said, this is going to require the best minds across the physical climate sciences, but the social sciences as well, and particularly engaging with our early career researchers, the next generation, not just of scientists, but leaders. So that's critically important, as is building strong partnerships. It also means improving the diversity of our community, and we're particularly keen to explore ways that we can better and more effectively engage and work with all of you. And we hope that this forum, at least as a first step, to explore ways that we can do that better. And so that's the end of the WCRP part, or session 2. And this is where we go and hand over to our Slido experts. First of all, Detlef, was there something you wanted to add? And then we'll get, some of you might want to be hopping over to Slido to ask any questions that you might have of us.
No, thank you, Helen, and thanks again for this wonderful summary of where we are. I suggest we move forward, because we are slightly behind the schedule, and we better give the community the floor, the possibility to ask questions. Thank you.
Thank you, Detlef. And I'm going to stop sharing now, because then I can see my chat and everything else that's going on. So, and between Tim and Amy, thank you, who are monitoring Slido, and Narelle, who's going to be showing any results. So let's start. Are there any 1 or 2 questions, Amy, that you'd like to read out to me?
The top question right now is, what model or methodology is WCRP using to communicate science to policymakers and the public?
Okay, Detlef, I'm going to give you first chance to answer that if you'd like. Or if you
well, I mean, this is a big question. I guess one of the things we like to think about is that, in fact, we produce the science that is important for IPCC actually doing its work. And to some extent, this is really a very important mechanism for us to communicate and to have the science being assessed. But then we are also very much involved in other UN discussions and platforms and So this is more on the higher level, but the next step would come down, in fact, climate services, where that information is being triggered and being communicated. But of course, at the end, on the national level, a lot of our communities work with local politicians, with local decision makers, where all that information can be triggered in. In fact, this is where I should actually give back to Helen, because she was active in this role and still very active in that role, to give examples.
Yes, and I just reiterate, in the interest of time, I won't say too much more, but communication is critically important, and often we do that in partnership by being involved in some of the, the high-profile reports that you might see coming out. Quite often the WCRP typically will be involved in providing the climate science into that. The most highest profile would be perhaps the IPCC assessment reports. WCRP science, of course, feeds into those, but there are others as well, like the United in Science or the global climate statements and so forth. So that's at the global scale, and then nationally we're also contributing, and then our core projects are also contributing too. So I do think it's a good question, and an active dialogue about how we could continue to enhance our communication. I am very conscious of the time, but Amy, is there one more? And then we'll go to the poll, I think.
Yes. What does WCRP see as their role in addressing proposed climate intervention strategies?
So I'm happy to answer that, and then Detlef can jump in. We see that it's very important that we have the science capability. By that I mean the process understanding, the simulation capability, so that we can explore what are the effects on the climate system, first of all, of climate intervention strategies, but any unintended consequences as well. And the only way you can explore that is through a simulation capability that brings in as much process understanding as possible about the interacting elements of the climate system. It's really important that we have that capability before we can embark on any of those strategies. And just to be clear, we're not saying that we are advocating for climate intervention strategies, but rather we are providing the science that's needed to assess their efficacy and their impact. Did you want to add anything, Detlef?
Well, no, I think this was very complete, except the one point is maybe it wasn't really highlighted on the slides that we showed so far. Climate interventions is a very important topic that is present in various of the Lighthouse activities and also the core project activities. But for the reason that Helen just summarized, we need to gain knowledge. We need to gain that insight that people want to have, that we actually can make recommendations or warnings, but not to promote it at this point.
And I should have added, I think you might have said this, Detlef, that some of our Lighthouse activities envisage including some of that science, but some of the science is also that's needed will be done in the core projects as well. Can we go to the Slido poll? I should, while that's coming up, just note that I gather there's lots of great questions in Slido. I don't have multiple screens, so I'm not going to look, but what we will do is those that were popular, we aim to draft a FAQ coming out of today's forum so that we can provide some answers to you all for some of your questions. So I'll read this out if that's okay. On a scale of where 1's weak and 5's strong, tell us how you'd rate our goals for addressing climate information needs. And we're going to do these quite quickly, so whatever answer comes quickly to mind. This is like multi-choice when you're at university. Go quick. So we should start to see some results coming up soon. Oh, and the second is, do you think Lighthouse activities are addressing critical science questions? And tell us how you think we could improve them. And I'll leave it to Narelle and Amy to decide when it's time to show some of the results.
Amy, is that from your side? Because this is what all I've got to show.
I don't have control over that, I don't think, although I see that 88 people have voted. Maybe I can, does this work? I just put show live, the ratings.
It just seems to show the questions. I'm not really sure why that is. Maybe we just need to move on.
We might need to move on. If we can bring those up later on, maybe we will. Is that okay? Sorry. As I said to everybody, this is an experiment being conducted in real time. So we anticipated a few hiccups. So if it's okay, I'd like to actually move to the next session, session 3, which requires me to share my screen. Briefly. Well, actually, I won't, just in the interest of time. I'll just go straight to our speakers. So we've got 3 really interesting talks coming up. So I'll hand over now to the first of those 3 speakers. This is Roberto Sánchez-Rodríguez. Roberto is a member of the WCRP JSC, and he's going to speak to us on climate information needs from a user policymaker perspective. Roberto, over to you.
Thank you, Helen.
And we can see you. That's all looking good. If you can just put it into presenter mode. Perfect. Thank you.
Well, I would like to begin by thanking the organizers for the opportunity to share with you some minutes. And what I would like to do in my presentation is to talk about the importance of climate science for society, but focusing more on the society point of view. As Helen introduced it, WCRP, most of the focus is to really help society develop more sustainable development in the future. But it's often not clear who is society, and this is one of the questions that struck me that appear in one of the discussions of one of the new core projects, the Regional Information for Society. Some people were asking, who is society? And I think it was a very interesting question. Let me just begin by highlighting that a number of international reports and international organizations point out that we are at a critical stage, and that the ways society has grown has represented a threat for the integrity of nature, and some call them the planetary boundaries that you see on the right. But it's critical to understand that what's going to happen in the coming decade is going to determine the kind of society that we look into the future. And some of the reports you are familiar with, definitely the IPCC, but some of the other reports you might not be familiar with is the IPBES, which is the equivalent to the IPCC for biodiversity and ecosystem services. And the other one is the World Economic Forum report. The Economic Forum presents a report every year on the critical threats for the global economy. What is interesting is during the last 5 years, the forum has identified climate change and loss of biodiversity and ecosystems as critical challenges for economic growth in the coming decades. Now, let me just start by highlighting some of the interesting studies. This is a recent study that's quite interesting. And what it does is identifies the human climate niche where society has lived during the last 6,000 years. And they identify what you see in the top row is that during the last 6,000 years, humanity has lived basically in the same climate niche, around 17 degrees Celsius. The interesting part is that the development of agriculture and livestock and the development of generation of GDP, growth development, is associated with where the people tend to live, the climate niche, but is not associated with soil fertility or potential productivity, which means that people tend to live, but not necessarily because it's constrained by nature in that sense. And on the right side, what you see is a number of maps at the current situation and how it evolves into the future, taken into the RCP 8.5. And the difference in terms of how the suitability of those areas where people are living will be modified for the coming decades. And what is interesting to note is that there is this band north and south of the equator that where the suitability for the human niche, climate niche, is being lost. Now, in the rest of my presentation, I'm going to use some of the, by all means, it's not comprehensive, but it will give you an illustration of what kind of society is being developed for the coming decades. And when we talk about using climate science for sustainability, it's important to understand what kind of society is developing in the coming decades. Now, this is another indicator that is common use in climate science, particularly in climate. Some of the climate services focus on climate-related hazards and disasters, and this is focusing on cities. And what you see is also that band north and south of the equator is precisely the most critical areas in terms of the density of hazards, climate-related hazards, but also in terms of the location of the population. It gives you an idea that climate-related hazards are an important factor for the coming decades. In terms of health, which is also another area where climate services have focused, it's the same story. I mean, what you see on the map on the right side is the global distribution of minimum mortality estimated by GRID, and the mortality rate, and this is the current in the last decade, the mortality is precisely more critical in the same geographical area across the equator where most of the developing countries are located. And of course, when we talk about climate and health, there is a number of variables that are important that will evolve in the coming decades. And what you see is the work of the IPCC on the left side, and the importance of malnutrition, vector-borne disease, occupational health, and food and waterborne infections. It's impossible not to recognize that in terms of health, one critical issue is going to be the emerging infectious diseases, and because of COVID-19, we made very sensitive about this, but the way the destruction of some key ecosystems have put humans in contact with key vectors that make us, that facilitates the sonic transmission of viruses to humans. And very interesting work has been done in that area. Moving on, and this is going into a different direction, and climate services have worked extensively on agricultural, health, and natural disasters, but not enough attention, I believe, has been paid, for instance, for economic factors related to climate. And what you see here is precisely on the left side, the map of the main change of hours lost per person per year due to temperature increase. And on the left side, what you see is results from an interesting study on regional changes in the economic competitive capacity and regional economies related to temperature change. Again, what you see is that what is evolving is those countries, those developing countries in north and south of the equator are precisely the kind of society that is going to suffer through this process. Moving on in terms of water, and this is the geographical distribution of drylands. This is a result from the IPCC report on land a couple of years ago. And of course, a good part of the developing countries are part of the drylands. And when it comes to related to water, you see on the left side is precisely those societies that are already showing critical stage of water stress currently. And on the right side is IPCC's projections from the last assessment report in terms of how that those water stress is going to be aggravated in the coming decades. And again, we're talking about a extended number of countries in developing countries. And related to water, of course, is the issue of food. And the world has already a quite significant stress in terms of meeting the capacity to provide everybody with food in currently. And some of the most stressful news currently had to do with hunger and in several parts of the world. But it's often not associated with a number of processes, socioeconomic processes that are directly related to food production and to climate, and that help us understand how the critical situation in those regions that are already suffering hunger could be aggravated in the coming futures. What you see on the left side is a map of transnational land acquisitions. These are massive land acquisitions by either countries or companies in different parts of the world, particularly in Africa, Asia, and parts of Latin America. And what you see on the right side is results of a very interesting study of how biocapacity has been appropriated through land grabbing, through land acquisitions by certain countries, and in detrimental of the bioproductivity of land in other parts of the countries. And those countries losing bioproductivity is precisely a number of significant countries, developing countries in Africa, Asia, and South America. Associated with this is how changes in the region lands are going to be occurring in the near future, and these are comparing 2000 with 2050, which is a critical stage. And you see the significant differences that will affect is part of the regions that are already under stress on the other factors that I just mentioned. I'm going to move rapidly to this. This is a series of information of kind of society that we try to understand to help them address climate science. Has to do with the concentration of wealth in a number of countries, but even within countries, and the increasing of poverty, for instance, in certain parts of the world. A recent report of the World Bank on poverty associated the increase of poverty due to COVID-19 and estimates that 100 million extreme poor have developed through COVID-19, but they also associate the increase in poverty through climate change and also armed conflicts in different parts of the world. Moving fast on this, these are social imperatives and inequity in life expectancy. And you see, again, we are talking about the kind of societies in developing countries that are going to suffer significantly in coming decades. Fragile and failed states are precisely those countries that we talk about, and the Global Peace Index is precisely the same part of the world that we discuss it. It's not strange to find out that a significant part of international migration, and this is the map on the left side of your screen, is coming from those countries that are suffering by a number of social, political, or socioeconomic and geopolitical factors, but also by biophysical changes that affect the capacity to maintain livelihoods and to develop opportunities for sustainable development. To aggravate the situation even more is the fact that current growth in developing countries is particularly dynamic. If we take into consideration that future population growth on a planetary level is going to be concentrated 90% in developing countries, and within those developing countries is going to be concentrated in Asia and in Africa. This gives you an idea that in the future, we are actually talking about existential risk for society and nature. And these coming decades are going to be critical. It's fantastic that WCRP is restructuring its operation to respond in the coming decade to many of these societal changes, to at least make an effort to help societies be aware of climate risk and the challenges that climate represents for them. whatever we do in the coming decade is going to be critical. By 2050. The world is going to be very different. Society, as we know it now, is changing very rapidly, and these are just some variables that try to illustrate the dynamic of change in society. And whatever we do in the next coming decade is going to be a detrimental, a definite factor for 2050. Now, in terms of the difference between climate science and climate services, and this was another question that appeared in one of the working documents of the new group project for regional information for society. How is climate science different for climate services? And I believe there is a substantial difference between the two. Climate services, and particularly, I'm not an expert in climate services, but just preparing for this presentation, I look into some of the climate services, particularly the International Research Institute and Columbia University that has 20 years experience of climate services, and also the Climate Services Partnership in Europe. And what they're trying to do is to move from case studies to becoming more stable. But they're focusing on a very specific niche, agriculture particularly, and to some extent health and hazards and risk. But I believe that climate sciences have a more in-depth and role in transforming societies to actually accomplish what Helen described as the climate science for a more sustainable world. Now, how we do this, and this was the first question that was posed to Helen, and the science-policy interface for the climate sciences is quite interesting, and the literature looking into what is the best approach to deal with science policy interface has different perspectives. One of them is that they consider the science and the policy domain as two different worlds, and with different operation cultures, different needs, different values, and different time frames. And it's often difficult to reconcile these worlds. And what they see is the importance of creating a middle space between these two domains, where these science community and the policy community come together and communicate and try to develop understanding and find the best interface possible to communicate science into policy. However, there is a lot of perspective that talks about we are only one world, and particularly for climate science, this perspective takes into consideration that a number of decision makers in the climate domain have an academic training, have a scientific training, and for them, it's important to consider only one world where the science and policy work together jointly. There are some voices of concern about this perspective because some fear that the science community could lose the independence if it's merged together as a single approach. In between of them is a recent proposal suggesting that we rather think about this in terms of a gradient that goes from the two extremes between science and policy, but that have set very deep into communication, and where the interaction between the science and policy is bridged to intense communication, but also to the participation of other members of society. It's not only important to talk about science and decision makers and science and policy, but to incorporate other members of society. And this is very appropriate to our times where a number of social groups, our business community by itself, have demanded to be participants of the decision-making process that affects future climate. And this is very appropriate also for the new structure of WCRP, particularly the new activities through the Lighthouse projects, but also through some of the new core projects and some of the existing core projects. And I'm going to stop here and just wait if there's any questions. Thank you.
Thank you so much, Roberto. That was really relevant to some of the questions we've been receiving, but also to provide even more context for what we're doing in the WCRP, including some of the goals for these regional forums where we are trying to strengthen our engagement through parts of the world historically we've not been as strong. So thank you so much. What I'm going to do actually is go to the next speaker. Slido is open, so you can hop over there and start posting your questions, and we'll take all the questions at the end of the session just to keep us moving forward. I'm hoping you'll all be good at multitasking and listening and posting your questions. So thank you again, Roberto, and we'll come to some questions at the end. But now I'm going to invite our next speaker, who is Susann Tegtmeier. Susann has been involved in the WCRP for quite some time. She's part of one of our Lighthouse activities. She's also leading the charge for developing one of our new core projects. And she's going to speak to us today on another important dimension of the WCRP, which is around our observations and the role they play in assessing climate risk. So Susann, over to you. You can share your screen.
Thank you. Helen, can you see my screen and can you hear me well?
Yes, yes, and yes.
Okay, thanks. Good. I will talk about the Earth system observations for assessing climate-related risks. And I will do this in the context of the WCRP. So as you've heard earlier from Helen, most important elements of the WCRP are the core projects, which are the homes for the WCRP communities, and they're shown here on the left hand. And then we also have the lighthouses that are shown on the right hand, the newly established lighthouses. And in this presentation, I will quickly come back to one of the lighthouses, to my climate risk, just say a little more about this lighthouse activity. I will also tell you something about the new home on the Earth system modeling and observations. And then I use the second part of my presentation to talk about the climate observing system in general. But let's start with the WCRP Lighthouse, My Climate Risk. So this activity really has the vision to bring together the process understanding, the models and the observations in order to provide meaningful information on climate risks at local and regional levels. I can go through this rather quickly because Helen already talked about it. It will develop a bottom-up approach that will start from the decision context, and then in this decision context provide these meaningful climate informations at the local and regional scales. And what I would like to stress here is that it's the idea behind this activity is to not only apply this approach to various local questions and climate risk studies, but really to develop a new framework. And that new framework, if successful, will then be generic, it will be flexible, and it can be applied to a number of different climate risk problems, to different regions and to different groups. So that's the basic idea behind it. I have one practical example here that is on droughts in South America during austral summer. You see precipitation anomalies, and then in a box that shows up right beside this plot, you see this decision context, so questions that arise from such events, questions that energy companies have, or water supply companies, or the farmers. And this is the point then where the lighthouse, the climate risk lighthouse, will come in order to support local researchers who might not have the experience or might not have the network, in order to help those researchers to answer these questions, in order to bring the expertise to discuss which protocols to use, who to talk to, which data sets, models, reanalysis, observations to use in order to provide information on the risk. So here you see just a quick list of the members of the lighthouse, together with the geographical distribution, also the communities that they are representing at the career stage. As I said earlier, the overall goal is to come up with a new framework. The way it will start, though, is by tackling individual regional climate risk questions, setting up what we call labs at the moment. And these labs can have very different formats. They can come across in form of workshops. So right now we're discussing setting up some very first workshops. There's one idea of organizing a workshop for regional climate information in the Himalaya region, together with the Himalayan University Consortium. And there's some other ideas as well. So if you or your research group, if you're interested in such a lab for some local or regional climate risk assessments, you can get in contact with the members or with the co-chairs of this Lighthouse activity, which are Regina Rodriguez and Ted Shepard. Now, after talking about the Lighthouse for a little bit, I'd like to switch and come to the new home, the home and Earth system modeling and observations. So the vision here is really to bring together all activities in WCRP that deal with observations, that deal with models, and that deal with data, and to do this in a way to establish an overall coordinating mechanism. So if you think of the structure of this new model data home, it will have a scientific steering group, then it will include the current groups on modeling, so current working groups on modeling, such as the working group on coupled modeling or numerical experimentation. It will include groups that work on reanalysis assessments or on seasonal to sub-seasonal predictions, and it will include panels on the observations, such as a panel that will coordinate the observations within WCRP or the Ops for MIPS panel. There's also a lot of room to take up new topics here. The obvious one would be data science. So that's just ideas for future groups that would come in. And then of course, the new home will build up a lot of partnerships internally in WCRP. Those are shown on the left-hand side, and then also with external partners, which are highlighted here on the right-hand side of the box. Thinking about the goals and the outcomes of this new home, I've structured them here, sorting them in 3 groups, basically. One is on the research aspects, one is on a lot of methodological aspects, and one is on communication and strategy aspects. And I don't want to go through them individually, but just highlighting some. So the main idea and motivation behind the new home was to bring models and observations closer together. So that's what you see as the first point here, this combined model observation approach that should be based on a seamless and value chain approach. And then the third point I would also like to highlight, in addition to optimizing the model development, this home will also look at the observational requirements of the WCRP community, the observational requirements of the core projects, but also of the new Lighthouse activities. Again, here's a list with the people that are involved, that are forming the current interim scientific steering group. And this new home is indeed very new. We just had the first meeting of the interim steering group exactly a week ago. So we started discussing the way forward. And I just want to highlight here of what I think might be some of the really upcoming challenges. First of all, to set research priorities, but also to set the governance of the home. So how should it work? How do we really bring the models and the observations closer together? What are the terms of reference and the structure? And then finally, to establish the external partnerships. So now after I've shown you these 2 more structural elements, the Lighthouse and the new home on the modeling and observational capabilities, I would like to say a little bit about the climate observing system in general. And let's start here with the big question. So what climate observing system is needed? And what we need, obviously, is a climate observing system that is specifically planned and designed for us to understand the critical aspects of the climate system. And I will come back to this term critical or important aspects a bit later in this presentation. It should certainly include extreme events such as hurricanes, heat waves, droughts, so that we can assess the hazard component of the climate risks. Now, such an observing system will serve multiple purposes. It will help with understanding the climate system at the process level. It will help with the scientific uncertainties. It will help with initializing and testing the models in order to enable predictions and projections going from sub-seasonal to centennial timescales. It will help us to quantify uncertainties with respect to mitigation, adaptation, and potential responses. So lots of advantages here. And we should point out that there have been many national efforts over the last decades, and they have been very successful in establishing some important components of the climate observing system. On the other hand, it is important to keep in mind that there's no international commitment on building and maintaining such an observing system. So on the international stage, what we have at the moment are various bodies who coordinate the observations. And this coordination is of course important, especially in the WCRP context. So let's just look into the coordination for a second, and then I will come back to the general climate observing system question. So coordination can happen through various bodies. I think for WCRP, most important is the Global Climate Observing System, GCOS. So I will just focus on GCOS here. And GCOS does a couple of things. Most important, it assesses quite regularly the status of global climate observations. And more important even, it produces guidance for the improvement of such global climate observations. So this is then published in these GCOS implementation plans or in the status reports. And the implementation plan and status reports focus on essential climate variables, the so-called ECVs. You see here our atmospheric, ocean, and terrestrial ECVs listed. And the information that you find in these reports is really a summary of the adequacy of the ECV observations, of their availability, and of their stewardship. And this information by itself, as it is provided by GCOS, is extremely valuable for the community. I found this interesting graphic here that has been published by Trenberth et al. In a book chapter in 2013, linking the information on the ECV monitoring to our ability to address long-term changes of extreme phenomena. And so you see the extreme phenomena on the x-axis and the ECVs that are needed to address the individual phenomena on the y-axis. And I had to cut out the ocean part, not because it's less important, but just because my slide was too small. So there's a part in the middle here. Anyhow, what I really would like to highlight is that with this color coding here that they've used, and using the green, yellow, and red colors, we can really see for which of the extreme phenomena the current monitoring system is adequate in order to capture the trends on climate timescales. And if you see green, you have this adequate monitoring system for that particular ECV that then is needed to address the phenomena. If it's yellow, you miss one important characteristic, and if it's red, you miss more than one. Now, coming back to the GCOS implementation plan and their status reports, once these documents have been published, they go to the national agencies, to the climate observing systems. Here I'm just highlighting the communication between GCOS and the satellite community. So this is here the working group on climate that represents CEOS and CGMS. And this working group on climate looks at the GCOS report and then really drafts a coordinated response. And these responses are actually accessible on the internet. Everyone can go and look at them and download them. So that's basically the response of these two satellite groups in order to the climate observation requirements that are highlighted in these reports. Now, where does WCRP come in here? First of all, of course, WCRP has a large amount of input to the status report and the implementation plan. So that's the direct link on the right-hand side. On the other side, it is important for the WCRP community to also have direct interactions with the observing system agencies, or with the working group on climate in case of the satellites here. And this is a place where the new home will come in and can really establish this interface between the science communities and GCOS and the space agencies and contribute to the observing system design. Okay, coming back to what we started, what climate observing system is needed. Now we talked a little bit about the coordination of the climate observations, but what about the climate observing system itself? As we said on the earlier slide, we want this climate observing system that's planned to adequately address the full range of climate needs. It has been noted in publications now that such a system has never really been established in a systematic way. Instead, the climate observing system suffers from disruption or is driven by engineering developments, might just focus on individual questions instead of the overarching critical issues that we would like to address. So there are now a couple of proposals that discuss how to address these shortcomings, how to design a climate observing system of the future. And while there are different proposals out there, I just want to highlight one here that's published in Weatherhead et al. In 2018. And in this publication, they propose that the WCR community, the climate research community, needs to prioritize the observations that are needed, and they need to prioritize these observations according to the climate goals and according to the societal needs. So these are the two important factors that come in. Once climate goals are defined, we need to identify the observations that are required in order to address those climate goals, and we need to distinguish between observations that are needed for long-term monitoring of these climate goals, for process understanding, and for the forecasting capabilities. And they've actually showing this in their paper for the examples of the WCRP Grand Challenges. So again, this is just some part of their figure. So here for the Grand Challenge on understanding and predicting weather extremes, and then just highlighting some examples for observations needed to address this Grand Challenge, falling into this monitoring, understanding, and projection categories. Then in the second part, as the second part of this proposed approach, the paper really highlights how an objective evaluation of the proposed observing system is very critical, and it's required in order to quantify the ability of whatever is proposed to address the climate priorities. And they also make a very important point how all parts of the observing system need to be included, such as satellite ground-based observations and the in situ observations as well. And then finally, and they provide some very convincing motivations why the investment in an effective climate observing system is economically important, and how this will really offer a magnified return of the investment. So with this, with this proposal here and these thoughts, I would like to come to my summary. So now I'm thinking about WCRP, thinking about what we just heard about the existing and well-established core projects and WCRP communities, and thinking about the new Lighthouse activities that will come to life over the next months and years, and about the new home on the Earth system modeling and observations. I think we are in a very good spot to talk and discuss our observational needs. And there are obviously various aspects that are important, such as the coordination of the observations that are available to us, but also the discussion really of the critical observational needs that we will have in the future. And I think these prioritizing and defining these needs should not necessarily come from the grand challenges, but should come from the WCRP science communities and from the Lighthouse activities together. It should be something that can be coordinated by the new home on modeling and observations. And then just as a last point is evaluation of the proposed observing system. Obviously, that's also a very important point, and that's something where the WCRP community can collaborate with the climate observation programs. And hopefully this will bring us a step closer to climate observation system that we need. Okay, thank you. That was all I had for today.
Thank you, Susan. Thanks so much for taking us through that and providing that next level of detail and information about your vision for, and I just wanted to say to the people online, you have heard us talk about homes and core projects. They are interchangeable. So if it's the language we're still working through. Core projects, as Detlef said, have very strong brand definition recognition. So we're reluctant to change that language, but when we're introduced the new core projects, the community really resonated with this notion that these were enduring homes for the capability. So we're still working that through. But in case that's confused you, I just want to let you know that we talk about homes and core projects interchangeably, but it's good to see the thinking around the new core project that Susann's presented. So hop on over and post some questions. And we are now going to move to the third speaker. Actually, one other thing I wanted to just thank Susann for is throughout these talks and today, it's really important to be thinking about what's the role that the WCRP can play in this global ecosystem around climate. And it was good, Susann, to hear you reflect on the role that the WCRP can play in that ecosystem. So our third speaker today is going to be talking to us about modelling. And so it's with great pleasure that I introduce Andy Prane from NCAR. And he's actually involved in one of our Lighthouse activities, the Digital Earth Lighthouse activity. And I'll hand over to Andy now for him to share his screen, and he will talk to us about advances and challenges in global and regional climate modelling. Thanks, Andy. And I can see your screen, and I'm sure we're going to be able to hear you.
Yeah, thank you, Helen, for the introduction. Let's switch gears, going to climate modeling, and I'm talking about recent advantages and challenges in regional and global modeling. And I structured this talk in 3 parts. I wanted to give you my perspective of why I think kilometer scale climate models are a big deal. I will talk about what I mean with that. I have 3 examples here that I will walk you through. I will talk about the dawn of a new era of climate modeling using these kind of models, and then some challenges and prospects, and also how WCRP can help with moving forward quicker in this direction. So let's start. I will talk about kilometer scale modeling, and I separated these in 3 points. First, simulating the water cycle in the Rockies or in orographic regions in the western part of North America. Then doing the same thing in the plains, where different processes are important. And then last but not least, looking at a model observational comparison. So I think this fits really nicely to the last speaker. So let's start with simulating the water cycle in the Rockies. Of course, these are very complex orographic regions. The Western United States, for example, or Canada, where we have really complex topography. We need high resolution models to simulate precipitation, for example, in this region. So the water cycle in the West is heavily dominated by snowpack and snow processes. What you see here is a cross section through the Colorado Rockies in a model resolution at 36 kilometers and 6 kilometers. And you see here in the vertical are updrafts and downdrafts in the model. And you see the interaction with the flow with topography is very, very different between using a 36-kilometer model and a 6-kilometer model. And in fact, you really need this narrow up and down drafts that you see here in red and blue to simulate the right accumulation and melt of snowpack in the right places. So this is just one example. If you compare 2 model resolutions with each other, using the weather research and forecasting model at 4 kilometers and 12 kilometers, what you see is the difference in annual snow accumulations in the Rockies of North America. And what's very obvious is if you have a 12-kilometer model, you heavily underestimate the snowpack that you should have in the coastal mountain ranges, but you overestimate the snowpack in the interior. The reason for that is basically exactly what you see here. There's a rain shadowing effect. So normally what you get is moisture from the Pacific. It hits the mountains in the coast. There should be a lot of moisture removed in these mountain ranges before it hits the interior. In the 12-kilometer simulation, you don't do that. You transport too much moisture in the interior, and that's why you get an overestimation of snow here and an underestimation here. Of course, this is bad if you're interested in hydrology in the western regions, for example, because you have to simulate the snow correctly to get the hydrology right. And this is just one example using a 4-kilometer model and comparing it to observations in this region here in the Pacific Northwest of North America. And what you see here is the accumulation and the melt of the snowpack in this mountain range over the year. And you see the model, which is red here, is doing a really good job in capturing what we observed there in the accumulation and melt of the snowpack. Very similar, this is the precipitation piece of it, so how much it rains accumulated over the water year. You see also there, the model is doing a really good job in simulating that. So high resolution modeling to simulate precipitation in the West is key. So let's move to the plains, which is a very different beast. Here, convective processes are really important. And I highlight one particular process, which is mesoscale convective systems. These are very large scale organized thunderstorms, and they contribute up to 70% of the warm season rainfall in the region. So up to 70% of all rainfall in the summer is coming from these kind of systems. They also are associated with major flooding, but also severe convective weather. So simulating those MCSs, mesoscale convective systems, is really important. The problem is really, if you look at the current global climate models and also global weather models that we have, they don't do a really good job in simulating these systems, and therefore we have very strong systematic biases in the central US, which are often way too dry and way too warm. This is, for example, the CAUSES project investigated this particular problem. So if you look at the grid spacing and sensitivity of simulating such mesoscale convective systems, you can see that there's really a step change in how you simulate those systems when you go from something like 12 kilometers or 10-kilometer grid spacing to kilometer scale or convection permitting grid spacings. And the major difference here is really that you don't need a deep convection parameterization anymore. So there is a parameterization, the steep convective parameterization, which is causing major uncertainties and errors in our simulations. And you can turn this off once you have this 4-kilometer and higher grid spacings, and you can see how different the precipitation looks like if you're at 12 kilometer or at 4 kilometer, and you see this very heavy precipitation pockets that you can simulate at this grid spacings, which are actually very realistic if you look, for example, at radar images or at large eddy simulations as we do here. If you're interested in simulating flooding, for example, simulating these heavy precipitation pockets is really essential, because you really have to simulate these areas of heavy rainfall accumulations. So we used a 4-kilometer model. So this is what we often use at NCAR to simulate the climate of most of North America. And this is one of the simulations that I'm showing you here. This is a 4-kilometer hindcast driven by ERA interim, so reanalysis driven, published in these papers. And we wanted to reproduce the number of mesoscale convective systems per season throughout the year, which is shown here in the central US. So basically, you can see in the summer season, in June, July, August, we have one of these systems almost every day. So when we did this with this 4-kilometer model, we were really happy because we were able to simulate the number of MCS really nicely until approximately June. And then afterwards, we plummeted. And we were really puzzled why this is happening, because in principle, you should be able to simulate those systems really well across the year. And it took us a few years to figure out why this is happening. And it turned out to be a land-atmosphere coupling problem. We didn't use a dynamic groundwater module in our simulations here. So this was very simplified groundwater treatment that we used, which is basically standard in most regional climate models. And once we turned on a dynamic groundwater treatment, you can see this is a temperature bias. We had up to 6 degrees, too warm temperatures in the central US. This almost disappears completely. So there's a very strong feedback if you treat groundwater dynamically on the atmosphere. You can also see that we repeated these simulations, but turned on the groundwater, and now you can see the number of mesoscale convective systems is really nicely captured by these new simulations. Also excitingly, even if you force the regional model over North America with a global climate model, so you don't need really a reanalysis driven run, but you can also use a GCM, and you still can reproduce the annual cycle really nicely, which is shown here. I'm showing this graphic also because we have a 12-kilometer counterpart, so the same simulation, just the coarser grid spacing, and you can see the 12 kilometers model is really failing to simulate the annual cycle realistically, even if you use groundwater. So you only get the right land atmosphere coupling strength if you go to this very high resolution of 4 kilometers or higher. This is a recent paper this is published in GRL recently that describes this issue. So last but not least, I wanted to talk about comparison between models and observations. I think there's really a paradigm shift going on where our observational capabilities are, or the modeling capabilities are approaching observational capabilities at the moment. So this is just one example here. We used the operational hydrologic model for Iowa and tried to simulate or forecast the total volume of runoff in their streams. And we used two different input data sets. The first one is an observational data set, which is a radar and gauge-based data set. It's very high resolution, pretty good data set. And then we also used our 4-kilometer simulation that we had over North America to force the same model. And this is a graphic that we produced in like a skill score and simulating total volume of rainfall. And what you can see, what was really surprising to us is that the model simulation, the model total volume forecast of runoff is exceeding, has a higher skill score than the one that we get from using the stage 4 observations. So there are several reasons for that, but I think this is really exciting. This is the season when we have the highest flood peaks in Iowa. So I think this is really a paradigm shift, how we should think about observations and models. And this is not a single study. There are multiple studies that point at that. And I think the paradigm shift is really to think more of a merging of observations and high resolution modeling as a best estimate for what really happened, because both of these observations and modeling have their deficiencies, and a joint approach is probably the best way to move forward. I just wanted to give you one demonstration of how realistic these models can look like. This is just looking at the cloud field in one of our simulations, and from the GOES 14 satellite. This was in June 2013. And I don't tell you now what the model and what the observation is, but I just wanted you to guess which one of those two cloud fields is coming from the satellite and which one is coming from the model. And it's really difficult to tell. I struggle with that. So the left one is the model and the right one is the satellite. So it's a really, I would say, a different kind of climate modeling. Once you go to this kilometer scale grid spacing, you get very realistic features in the clouds and the precipitation temperature and also snowpack. So I think this is really a dawn of a new era in climate modeling. I just summarized this in this graphic here. What you see is the horizontal grid spacing in our models, and this is the global coverage in case we use a regional model. So starting with global climate models, you can see from CMIP 1 to CMIP 6, we really increased the resolution of our model step by step. And at the moment, we are approximately at 25 kilometers with this high-res MIP simulations. The regional climate community basically follows a very similar trajectory, but of course, on the regional scale, we are pushing towards the right here, towards higher and higher resolution. We can look at what the kilometer scale climate community is doing. We started off with very small domains that we simulated maybe 10 years ago. And now we are going to more larger and larger domains, for example, continental scale domains. So we are pushing in this direction. And then, of course, there are some more experimental studies, which are fairly short, but they are using global models to simulate the global climate at kilometer scales. So this community is evolving really rapidly. This is just showing you the number of publications per year that deal with convection permitting or convection resolving modeling. So you can see this is really an exponential growth. I think the goal here that we can already see on the horizon is something like convection permitting Earth system modeling. And this is not an illusion. There are several really large scale projects internationally that have this goal, either in the US with NSF sponsored efforts, the UE sponsored efforts, the European Union is putting a lot of money in this kind of research, and also Japanese researchers are working on that. So in NCAR, we are mainly focused on continental scale modeling. We have several sets of high resolution of 4-kilometer models with the weather research and climate model over North America that are shown here. So we have several simulations that cover North America, one that covers Alaska specifically. We have nothing in the Caribbean and covering all of Mexico. So this is something we might consider to fill up in the near future. Just wanted to mention we have a big domain now as well focused on South America. One of these simulations, the CONUS 4.4, this is something we are currently working on. This will be a 40-year-long data set covering the reanalysis period, the satellite period. And this will be openly available data pretty soon. So we really committed to making all these data sets openly available. And those simulations will be key for future activities. For example, this one, a proposed regional hydroclimate project underneath GWEX for the United States, where we will use this high resolution modeling and observational transects across the country to better quantify energy and water cycles in the US. And if you want to learn more about this proposed RHP, look at this article here. I hope we can share the slides later on. So moving on to my last piece, which are challenges and prospects in kilometer scale climate modeling. So I think it's really about bringing together communities. So at the moment, like the climate modeling community is kind of isolated. So we are working in our own area. With these high resolution models, I think we are really overlapping more and more with weather modeling. So I think there's a real benefit of reaching out and combining these two fields. They're slowly merging, like these high resolution models are running on the same grid spacing, and these are basically often the same models that we use for weather forecasting. Impact research, once you're at this kilometer scales, you can really use this model output much more directly to do impact research. Might it be flooding or wind speed from hurricanes? They're all much better simulated at high resolution. Stakeholders and policymakers, I think, have to be involved in the design of these activities. These are really expensive experiments, and we have to make sure that the data is usable. Of course, observational science, as I said already, like a blend of modeling and observation seems to be a really good strategy in the future, but I think we need more observations as well to confront our models and to further develop the models. And then, of course, last but not least, this is more a technical challenge, but extremely important, computational science and software development. Our models will not be able to run on future high-performance computers, the models that we use at the moment. So we really have to think about how we run our models on future high-performance systems. So I think WCRP could be playing a really critical role here to bring together these communities, and that these communities start to work more and more together in the future. Second is the equitable access of data and resources, more open science. So what we really have to try to avoid is, like, these models are really expensive to run. So we should try to avoid that only a few centers around the globe that have the capability of running these models are able to do this research. What we should aim for is more this picture where we really share resources, we make this data available and include communities in the design of these experiments. I have a few key questions here. The first one is basically how to do this, how to involve these very diverse communities in the design of these experiments. One of the biggest challenges that we see at the moment is how we should share the data from the simulations. These are petabytes of data, and it's really hard to make them available publicly. We are really committed to do that, but in the future, this will be a major challenge. And then, of course, like how to train the future workforce that is able to work in such a diverse environment. I think we don't have a lot of people that are able to do this at the moment. So this should be a future high priority as well. And with that, I'm done, and I'm looking forward to some questions.
Thanks, Andy. And we're going to hop over to the questions on Slido in a moment. I just wanted to again thank all our three speakers just on Andy's talk. Thank you for providing the motivation for a digital Earth lighthouse. I think it was very clear through your talk, and even at the end why we're developing the WCRP Academy as well. But I also wanted to make the comment that Andy, when I introduced him, I should have said comes out of our GWEX core project community, and it's a nice example of the nexus, if you like, between the core project, foundational science, and how that's going to be brought into some of these new Lighthouse activities. So thanks, Andy, and thanks to other speakers. I'm now in the hands of Tim and Narelle to quickly, just because we're going to have to keep moving quite fast, but first of all, did you want to do the polls or questions? Tim?
I think Narelle is just kind of walking us through quickly the results from the previous poll, which we didn't display.
Yep. Okay, cool. Thank you.
So we can take a look at those, and then
yep, that's great.
I don't know if we want to say anything about them.
Oh, I think just go through them just to reflect on what it's telling us. because one of the things that we wanted out of these forums is to get feedback on some of the things that we're identifying. So seeing 80% of you thinking that the Lighthouse activities address critical science questions is really interesting. Now, these is an open-ended question. We won't be able to assimilate it all right now, but we will capture all this information and reflect on it. So thanks for giving us some ideas here. Yeah, and I can see lots of them about communication and bringing in a more diverse group of voices, and yeah, figuring out how to do that is what we're all about at the moment. So I think I saw one coming by saying they didn't know that WCRP doesn't have a high profile. I think that's right, and this is part of why we're doing what we're doing now. So thank you. Narelle, with us some more? Okay, so this is now a poll between the two. Yeah, over to you, Tim.
Yeah, Helen, I was just wondering maybe if we wanted to open the poll so people can be multitasking, and then maybe go to a few of the questions and answers for our panelists.
Yes, let's go to some of the top questions. Thanks, Tim. Are you going to read those out?
Yes, I will. So we had a few bubble to the top. I don't know how many we have time for, Helen, so just stop. But the first question was, how does WCRP interact, collaborate with WMO's Global Framework for Climate Services?
Right. Good question. I'm not sure if any of our speakers, if you'd like to answer that, please just turn on your microphone and jump in. But I'm also going to invite Detlef as the chair of JSC, but also close to the WMO Research Board as well, whether he would like to perhaps provide an answer to that one.
Are you waiting for the others to come in first? Or?
I just was hesitating to see no one's jumped in, so maybe you go first, Detlef.
Well, I mean, basically, this activity is in WMO. We formally invite them to our JSC meetings. We probably neglected enough dialogue in the past, but that was in fact revived, and so I think there's a direct connection to this group nowadays. There's also a connection through what is called the Research Board, which is in fact a group within WMO bringing together research activities within WMO, that is the WWRP and GORE plus WCRP, and there's typically a usual dialogue also with the climate service activity within WMO. But I think it is true that in the past that was not being fostered enough, and in the future, of course, in particular, our objective 4 will in fact build on a more intense dialogue with that group.
Yeah, thanks, Detlef. And I'd just add that though it's early days, at least one of the lighthouses is thinking about how the WCRP can formulate its research and thinking to provide guidance not to do the climate services, but to provide the science guidance for that. We unfortunately don't have time, as always happens, for lots of questions, but I just reiterate that we will try and provide an FAQ, but Tim, we could do 1 or 2 more, so let's keep moving.
Yeah, there was one question which, while we were answering this one, really kind of surged to the top of the pack. It may be directed more towards Andy, but I'll let you route, Helen. But the question is, how will this type of resolution model translate to the Caribbean or the Pacific, where the in situ observations are sparse?
Yeah, that's a good question. Andy, would you like, I'll give Andy first chance and then maybe Susan. So Andy.
I can try to take an aim on this. We have a similar challenge in South America where we simulate at the moment, where observations are way more sparse than in North America. Our strategy was really to involve the local community. So often local communities have additional data sets that are not openly available. So we're really working with like local Met offices or researchers, and they try to get as many observations as we can. We rely heavily on satellite observations, which cover, of course, like global areas with all their pros and cons. And I think we should also think about something like field experiments, where if we have specific scientific questions that we can address, we can formulate field experiments and try to get additional data this way, that we can improve the models in specific processes that are maybe key and not really well simulated.
Yeah, thanks, Andy. And thanks for the question, because actually, and I know we're short today, but one of the things that we'd like to foster out of these forms of engagement is to talk about the role that WCRP could play in supporting some of those gaps and needs that we see in other parts of the world, like the Caribbean, and how we can work with the local community there to bring our science. So now I'll just check, Susan, did you want to add anything? And if not, that's fine, but I wanted to give you the chance in case you wanted to add anything.
No, I don't have anything to add to that.
Okay, thanks. Tim, is there another burning question? Or if not, we'll go to the poll.
Well, there was one more that comes in third in the voting. What role truly plays uncertainty in an understanding of the predictions and projections in policy development? So that one might be a little bit more up Roberto's.
Yeah, thanks.
Ellie.
Roberto, would you like to speak to that one?
Well, it's a good question. I think it plays a major role. It's a matter of how different societies, different communities actually understand uncertainty. And I know that IPCC, for instance, is very careful in portraying uncertainty in the assessment process. However, for policy communities, uncertainty is not that well understood. And it's often a source of, let's say, debate with the scientific community. In the scientific community, we tend to be very, very careful with uncertainty because we don't want to overstep the research results. But often for the policy community, they would like to find a middle ground between our concern with uncertainty and the need for results as soon as possible. And that middle ground is often difficult to achieve. Some communities always work with uncertainty. I mean, the planning community within policymakers and decision makers work with uncertainty and is never really an obstacle to make decisions. The business community work with uncertainty also, and it's not an obstacle to make these important decisions. We need to try to figure out where is the middle ground where we feel comfortable with the kind of assessment we do, taking into consider uncertainty, and at the same time meets the needs not to wait for or to postpone certain decisions because we don't feel comfortable with a lot of uncertainty. It's one of those issues that needs to be worked out through the communication and this continuum that I was talking about in terms of science policy interface.
Yes, thanks, Roberto. And I would also just add to that very nice answer that this is something that several of our lighthouses are actually thinking about from different angles. So I think it's a good question. But we're going to have to keep moving. And I'm just going to ask Tim and Narelle, do we want to show the polls or would we do that after the next session? I'm not sure whether it's quicker and more efficient to do the polls now or later. Oh, here we go. Thank you. So we asked you what metric. And okay, so we're just asking the questions now, are we? Oh, here we go. Thank you. Okay, that's really interesting. Good, great. Well, let's just keep moving through them. Thank you for this reflections. And really appreciate your word answers as well, which we'll reflect on. Okay, some interesting ones coming up there too. Thank you. Someone said about presentations being available. The recording from this and the presentations will be available, so we can certainly say yes to that one. And we've seen the point about inclusion. Yes, we're very, very aware of that, and it's an active discussion at the moment in the WCRP about how we can be more inclusive. Okay. Yeah, and there's many of those ones. Okay. And yes, and the comment on South America, we're holding a regional forum like this one for the South American region, probably in the Southern Hemisphere spring, so probably September or October, and keep an eye out for that. We do take that point. Okay, maybe we can go to the next. Was there another poll question? Okay. Okay, so that was, okay, let's go to session 4 because we're running short of time. I'm going to hand over to Detlef and Roberto to take us through this session, but very briefly, just to say the intention. The intention was to hear from 4 speakers who are involved in research programs in this broader region. We've asked them to do a 5-minute response or intervention, and the point really is to see it's a first step towards what the WCRP might do next by way of another forum, a follow-up to this one that focuses on something that would add value to activities that are already being done in the region. So without further ado, I shall mute my mic and hand over to Detlef and Roberto to introduce our first speaker, Louis Uccellini, and to invite him to speak. So over to you, Detlef.
Thank you very much, Helen and Roberto. My suggestion is we jump in right into the matters because we are a bit behind schedule, and I would suggest I start with the introduction of Louis Uccellini. I'm really proud that I can introduce Louis here. He is the NOAA Assistant Administrator for Weather Services and Director of the National Weather Service. In his role, he is responsible for the day-to-day civilian weather operations for the United States. And equally important, Dr. Uccellini is also serves as the United States permanent representative of the World Meteorological Organization, which is one of our co-sponsors. So I'm really proud to have you here today. And every of the 4 speakers has 5 minutes for an intervention. And please go ahead, Louis.
So thank you. First, I just want to do the sound check. Make sure you can hear me.
It's excellent. And the slide is also excellent.
Okay. So first, I want to thank you for inviting me with this opportunity, speaking to one slide. Secondly, I've been listening very carefully to the talks, and it's another learning experience for someone who's been in the research community, but has also lived the research to operational paradigm personally, as I'm now the director of the National Weather Service and responsible for the operational aspects of delivering services based on all the great modeling work and other aspects in that value chain that gets us to the point where we're actually influencing decisions on a day-to-day basis. What I want to speak today is maybe a sunrise of a new grand challenge. I heard you talk about the sunset of the original grand challenges. I was involved in that first grand challenge there in 2010, actually from a 2005 to 2010 period as a member of CAS. Of course, this is the grand challenge that was brought forward through the WCRP and NCAS to develop a seamless suite of model applications based on the weather-climate linkage. Linking, and as I think we just saw in the last presentation, a really great example of what happens when you bring those models together. So today, what I would offer is that there's, I'm not sure we're actually done with that grand challenge, by the way, but let's move on to a newer version of it, which is based on the weather-water climate linkage, which was also noted, I believe, in the last presentation. But there's a lot more work that needs to be done to bring the water community, the hydrologic community, into what we're doing. And the water could also represent oceans, although the ocean community is more or less represented in the climate. We need that coupling between the ocean and the atmospheres if we even want to do the weather forecast, much less short-range climate and longer-range climate. What we've done in NOAA, and I've been the chair of this weather-water climate board that's pulled all the line offices NOAA together to vote on a new grand challenge, a precipitation prediction grand challenge. This is driven in part by the user needs for more accurate and consistent precipitation prediction extending from the mesoscale through the subseasonal, the seasonal scales. A lot of water resource management decisions now are made months in advance. If we look at what's going on in the Arctic, the ice forecasts are being requested at 30-day plus range for fundamental decisions. So it's clear that there's an aspect that must involve the water cycle if we are to move forward in these areas. There's a great interest in addressing the related prediction and predictability science and services issues, which are now tractable. And an example of this is the report that's just been issued from a workshop held last year on predictability research and development. That was in June of last year. And that's important across the board, even in a weather domain, where if we predicted an extreme event 7 days in advance, many of our users expect us to do that all the time. And the next case comes along and we have trouble predicting it 24 hours in advance. So you can imagine the predictability issues as you move that up in time. And this really manifests itself in precipitation prediction writ large. And the third bullet here is, so we have a tractable problem, we believe, that the observation and modeling communities are embracing the Earth system science framework for advancing the fully coupled numerical prediction systems for the mesoscale through the subseasonal to seasonal. And we have these seamless predictions now that are being used, I would say operationally, to address services, and they're whetting the appetite for a lot more. So you have a lot of users out there that are really pushing the envelope on their requirements based on some of the successes we've had, actually a lot of the successes we've had in addressing this climate weather water linkage. And an example of that is the prediction of extreme events, whether it's the hurricanes, the hurricane season outlooks, the fire weather season outlooks now, and then the fire weather events predicted, the potential for them predicted now a week plus in advance. So the appetite of the users that have to make very important decisions are being enhanced and really forcing us to start thinking in terms of this grand challenge and moving this kind of linkage forward to address what we hope are usable predictions for important decisions, especially in that week 3, 4, and beyond period. So why now? I think the challenges and related opportunities of advancing the research, accelerating the research to operations, and providing operational services to meet society's needs are all within reach. And I believe that's true out into the climate domain. But it can only happen through a collaborative effort involving global observation research and the operational enterprise. Regional experiments are being done and looked at, but it's going to take another global effort to really wrap our arms around this and especially deal with the predictability issues. And there's a whole bunch of hypotheses we could go through on that. So, the next steps, we would be asking for another opportunity to address the WCRP, to discuss this strategy in depth. There's further coordination amongst the WCRP, the World Weather Program, the Research Board, and the Hydrological Coordination Panel. These are all still viable, vibrant organizations within the new restructured WMO, but we have to bring the hydrologic community together with us and as we try to move this grand challenge forward. And I would also note, to invite the GOR, the aerosols are an important part of this issue. From an observation point of view, there's evidence to suggest that aerosols have as much impact on satellite-derived observations as unresolved clouds. So, as an example. So, and of course, the chemical and biological aspects of all the components of the Earth system are important in terms of moving this forward. So that's another aspect of this that I think we need to embrace. And I'll leave it at that. Thank you.
Thank you very much. This was a great summary, great input, and we move on to the next speaker. Roberto, do you want to introduce the next speaker? You're muted. You're muted.
Sorry, why don't you introduce the speakers and I moderate the discussion?
All right, so I will. John Pomeroy is our next speaker, and his video is up. John Pomeroy is director of the Global Water Futures Program, the largest university-led freshwater research project in the world. At the University of Saskatchewan, he is a Canadian research chair in water resources and climate change, a distinguished professor of geography, director of the Center for Hydrology, and director of the Cold Water Laboratory in Canmore in Alberta. John, please go ahead.
Well, thank you very much. It's wonderful to be speaking to this symposium. And I will just start my slides here. There we are. So I'll be talking about water futures. We had the segue to the hydrology community, and I'll be dealing with that in the context of global change. The Global Water Futures program was set up in 2016 by the Government of Canada. It was the largest water study in our country's history, and we think it's the largest freshwater study perhaps now in the world. Its mission is to find solutions to water threats in an era of global change, with objectives of improving disaster warning in Canada, so floods, droughts, and water quality episodes, predicting water futures using climate models and coupled water models, land models, aquatic models to look at future water conditions for Canada and beyond towards the end of the century under climate change and development, and work with users to inform their adaptation to change in response to changing water conditions and their management of risk. And a lot of the climate change impacts in Canada have been manifest by a dramatic increase in flood activity across the country, but we also have droughts. And just talking to one of the water managers in British Columbia this morning, who is managing both floods and droughts at the same time right now. So that's the worst case. The program itself involves 64 projects and core teams with almost 190 investigators at 18 universities across the country. And we have almost 500 partners that we've exchanged letters of support with across Canada. That's crucial for us, and it perhaps is a lesson for WCRP, or a trick is that transdisciplinary research. Stay out of the institution, make sure that you start off with user consultation and maintain it by continuous knowledge mobilization through these projects to make sure that we're on track with providing information that our users need. Of course, we also will want to make sure that we're doing things that are scientifically credible and at the cutting edge, but we found, I think we can do both. One area of particular interest for Global Water Futures has been working with Canada's large Indigenous community, our First Nations, Métis and Inuit people across the country, and engaging them on discussions on climate change and water security. And in fact, we've held the first national scientific meetings on First Nations managed territory, the first one at the Six Nations of the Grand River in Ontario in 2018, but we've continued to do that and have joint research projects, co-led, co-developed research projects with First Nations across the country. Moving to things that perhaps of interest to WCRP, we have developed a coupled water observation, data management, water prediction, and knowledge mobilization strategy. It starts off around 7 large basins across Canada, river basins, most of which are shared with the United States. It's 5 million square kilometers, so it's massive. But over these, then we have atmospheric models, hydrological models, water quality models, but also 60 water observatories for data simulation. And then we work with the provincial and federal agencies to bring more data in. We developed a data management system, GWFnet, and we're providing forecasting systems for others to apply, but also looking at future water conditions using coupled models looking at climate. I'm going to zoom in now to the Canadian Rockies Mountains, where we have observatories such as Fortress Mountain up here. This is an area of deep snowpacks, glaciers, as over 60% of the water supply coming from melting snow, and it's very impacted by warming climate. We've been able to drive models, in this case using Environment Canada's high resolution deterministic prediction system. It's at 2.5 kilometers and it is convective resolving and at a suitable resolution for application in the model in the mountains. We also use WRF pseudo-global warming at 4 kilometers for future climate runs. Again, we want to have that convective permitting high resolution systems in these environments. We've been using the GEM model from Environment Canada to drive a new model we call the Canadian Hydrological Model. Right now it's a snow model, but we're extending it to the full land surface and hydrology, but it rescales from 2.5 kilometers down to 50 meters using complex terrain wind flow, lapsing meteorological parameters, radiation to the slopes and elevations, calculating blowing snow transport, avalanching, forest snow impacts, snowpack energetics, energy balance, snowmelt. And we find that with this sort of resolution, we can get snowpack simulations that are very close to what we might measure with airborne LiDAR. And if we don't, we get this smear in the mountains that simply gives us very poor inputs. We've also been providing a test case as a public operational model we call Snowcast to allow us to apply this over a large area. And this is over 186,000 kilometers at 50 meter resolution TINs. And we can run a model like that in a day. So these things are certainly feasible and suitable for global application. They're particularly important in our part of the world. The Calgary flood of 2013 was the largest, most expensive natural disaster in Canadian history at the time, and it was rain on snow. And so this helps us drive better national models of these types of things. And the GEM Hydro prototype showing here certainly is better informed by having an accurate snowpack at the start of this particular flooding event. So internationally, what we're starting to do now is take the GWEX InArch project of Alpine Research Catchment Hydrology, and then use that to apply some of these models around the world. And we have particular initiatives in Asia, in Central Asia, and in South Asia, looking at the Ganges and in the upper reaches of the Sir-Daria Basin. At this point, we're also working with collaborators in the Andes on model application in that region. So we want to take our focus area and our strengths, which are cold regions, and go to global cold regions, the headwaters of major river basins that support much of the world, and try to work with them. Again, user engagement is critical on any venture like that. So I'll wrap up there, and thank you very much.
Thank you very much, John. Very, very interesting. And in the sake of time, we move on and we come back later for questions. I would like to introduce the next speaker, which is Anna Stewart. Anna Stewart is the scientific director of the Inter-American Institute for Global Change Research, probably also known to many as IAI, an intergovernmental organization based in Montevideo in Uruguay. So Anna, please go ahead.
Thank you, Detlef, for the introduction, and thank you to Helen and the rest of the WCRP team for the kind invitation to participate in this event. So as we've heard from colleagues today, there's an urgent need for science, policy, knowledge, and tools to address the global environmental challenges that we face collectively. Global environmental change, by definition, transcends national boundaries, and effective interventions require a coordinated multinational response. Countries across the region are searching for meaningful adaptation and mitigation strategies that reflect their local realities and needs, and this search for solutions is more urgent than ever. To address these challenges, countries from across the Americas came together almost 30 years ago to establish the IAI, an intergovernmental body with 19 member nations. And the IAI is guided by principles of scientific excellence, international cooperation, and full and open exchange of scientific information relevant to change. The IAI works across 3 interconnected areas in governance, science, and capacity building. And it's important to note that the IAI does not propose or promote specific policies. Rather, we support science that countries can use to take informed decisions. The IAI focuses on transdisciplinary science because this approach increases the likelihood of the research being used in policy decisions by providing mechanisms for meaningful stakeholder involvement through co-development and other processes. The The IAI's strategic plan focuses on science for the sustainability of the Americas. This 25-year plan lays out 8 cross-cutting goals put together at the Science Policy Interface. Although several of the goals explicitly focus on climate and water, it is clear that climate and water cut across all of the priority areas. And the goals in our strategic plan are connected to our science agenda, which has 4 pillars: human dimensions of global environmental change, and human dimensions transcends and cuts across all of our pillars: climate change and climate variability, ecosystems, biodiversity, land use and cover, and water resources, and global change modulations of the atmosphere, oceans, and fresh waters. For the last 25 years, the IAI has funded collaborative research networks known as CRNs. The most recent iteration, CRN3, ran from 2012 to 2019 and supported 17 research networks across 15 countries. The CRN3 special issue was recently published in the journal Environmental Development. The articles are open access, and here you can see some of them that feature work on water and climate issues across the region. We are currently sponsoring a small grants program on biodiversity, ecosystem services, and human well-being across 10 countries of the Americas. Each transdisciplinary research team has investigators and stakeholders from at least 3 countries in the region, and they are working to do science to support policy and decision-making needs. Water and climate emerged as central themes in 4 of the 6 projects that I've highlighted here, and you can see the PIs on the left. Finally, I'll mention that the nexus of climate, environment, and health has emerged as an important area of work, and certainly this has become more urgent in light of the COVID-19 pandemic that we continue to live in. We are currently supporting the development of adaptation actions for climate and health in the Caribbean region as part of the pilot program for climate resilience, also known as the PPCR, coordinated by the University of West Indies. And this work is led by the Caribbean Public Health Agency, CARPHA, in partnership with the Caribbean Institute for Meteorology and Hydrology, CIMH, and national health and climate sectors in St. Lucia, Jamaica, and Haiti. And to wrap up, I've listed a few upcoming activities from our science and capacity building program, and I encourage you to read more on the IAI website. In the coming year, we will continue to develop regional training activities and grant calls around transdisciplinary science and science diplomacy. Some of this work will be coordinated with the Belmont Forum, a global consortium of science funding agencies. Of note, a collaborative research action is being developed to focus on climate, environment, and health, and IAI will be leading the regional scoping workshops in the coming months, so be on the lookout for those activities and opportunities to participate in scoping. And those scoping activities will help to guide the writing of the call text to identify what will be the funding priorities. Finally, I want to highlight the new STEP Fellowship Program. This is an innovative program that places early career scientists with government agencies to improve the uptake of science in decision-making and policy processes. And this program was modeled after the AAAS Science and Technology Policy Fellowship Program, and it was launched this past year for the first time in Mexico and Argentina. Thank you again for the opportunity to participate in this event, and please do not hesitate to reach out if you have any questions or if you want to learn more about our work at the IAI. Thank you.
Anna, thank you very much for this great intervention. Again, for the sake of time, we move on, we come back to questions. The last intervention in this session, before we get to the questions, is actually provided by Dorte Dahl Jansen. Dorte is from Denmark, and you might wonder, why is somebody here from Denmark? We actually have a regional climate research forum that includes Greenland, and that's in fact a good reason to have Dorte here. Dorte is from the University of Copenhagen, the Center of Excellence for Ice and Climate uses ice core data to gain knowledge on the climate in past warm climate period, especially the Eemian period. And so, Dorte, you have the floor.
Thank you very much. I need to mention that I actually has a position as Canada Excellence Research Chair at University of Manitoba in Canada. So I do have my feet in North America. But what I'm going to talk about is the melting land ice in the Arctic, which I think is a very important thing in this area, that doesn't just impact North America, but actually impacts globally. But first, I work mostly with ice core science and looking to the past and using the information from the past to understand the climate system and that will allow us to make better predictions for the future. So we work on the Greenland ice sheet. We drill the deep ice cores, 3 kilometers deep. And it's an international project with a strong collaboration with National Science Foundation, flying with the big Hercules planes with skis on. But if you look at what's happening, you all know that the Arctic is warming much more than the global warming. That's the Arctic amplification. So in general, we have the double warming in the Arctic than we have globally. Of course, this impacts the ice on the North Hemisphere, and the ice will melt and produce sea level rise. So just to mention an example, when we look at the predictions for sea level rise, I will mention the case from Copenhagen. And in this area, the prediction is that the sea level rise will be 60 centimeters in year 2100, but the error is 60 centimeters too. So it's 60 centimeters plus minus 60 centimeter. And this is probably the most dangerous uncertainty we have, because will the sea level be 0 or will it be 1.2 meter? That's really an enormous error bar to work with. And to know more about the melting ice is enabling us to reduce this uncertainty, which I think is really important. So if you look at the contributions to sea level rise, you can see that the glaciers and Greenland is mainly the contributors from the Northern Hemisphere. And you can see from the period from 93 to 2004, the contributions was around 1 millimeter from these glaciers, the blue and light blue blocks there in the pie. But if you go to the next decade from 2004 to 15, you can see how especially the contribution from Greenland has increased a lot. So we are actually closing into 1.5 millimeters from Greenland. So Greenland is really the awakening giant that's beginning to contribute a lot to sea level rise. So we see that the ice is melting. The satellite observations are immensely important for getting the full understanding of the melting ice. And here you see the satellite measurements from GRACE, where you see that Greenland gain mass in the winter and lose mass in the summer. And you can see that all years are not equal. Sometimes, like now, 2012, we have a really strong melt in the summer. And if this curve continued, you would see that 2019 and 2020 has been great melt years as well. So in general, you can see in the average, you can say that the mass loss from Greenland is 281 gigatons per year, which is equivalent to 0.8 millimeters of global sea level rise per year. And we expect that this will increase in the future. So a last slide here, just to go back to the ice cores and what we see from the past. 120,000 years ago, we had the climate period, the last interglacial, also called the Eemian. And this climate period was characterized by being quite a lot warmer than our present interglacial. You can see the full climate curve here from the ice cores in the bottom. And you can see the time scale from 0 to the left to 120,000 years to the right. And when you compare the global, the interglacial, the present interglacial, the Holocene with the Eemian, we can see that it was actually 5 degrees warmer over Greenland at this time. When we run our models and look at the ice core data, we conclude that not more than 25% of the Greenland ice sheet was lost at this time. And this represents no more than 2 meters of global sea level rise during this period. So the Greenland ice sheet is actually more resilient to the warming than believed earlier. But as we know that the sea level rise in this time was 6 to 9 meters, we also know that as the warming continue, Antarctica will start to contribute too. So we will get quite a big sea level rise in the future. Now, with most of the scenarios for the future, we will get a warming over Greenland of 5 degrees, I guess probably before we reach year 2100. So getting into this scenario is very realistic for our future. Of course, it takes a long time for ice to melt. So it's not enough to reach the temperature. We also have to give the ice enough time to melt. And to reach 6 to 9 meters, I would say we're talking more the scale of 500 to 1,000 years than less. So it's not going to happen immediately, but we are dramatically changing the climate and increasing the sea level. And I think that was my last slide. Thank you very much. And thank you very much for giving me the opportunity to present this subject at this wonderful meeting.
And I thank you very much for this intervention and the contribution, great contribution. I actually now turn over to Roberto, or in fact also to Helen, to get some advice on the question session, given the time we are up for. Helen, do you have any suggestion how we do this?
Yes. So thanks, Detlef. Sorry to jump in there. I've just sent a note on chat box to everybody. We're going to keep the forum open for another 15 minutes. So I think, Detlef, we can have 5 to 10 minutes. I know it's much shorter than we originally hoped, for some questions from Amy and Tim. So Roberto and Detlef, I think if we could just ask, is it Amy for this one? Sorry, I've just lost track who's going to be reading out the questions.
It's actually Amy. Amy,
yeah.
I was told earlier. Yes.
Yeah. So if we could just go for her to read out some of the questions, that would be great. Thanks.
Sure. The top question is, what are the early career opportunities available in WCRP?
Okay. Well, these are not exactly questions to the intervention.
Yes.
The speakers, but either Roberto or we can actually pass this on to Helen to answer this.
So the question, Amy, was what are the top early career opportunities in WCRP? Just checking that I got the question, sorry. Well, I guess I actually talk about this in my very last slide at the wrap up. We have a couple of communities that are supported through the WCRP for early career scientists. The most prominent and relevant is YES, the Young Earth System Scientists community, who, if you don't know about them, we can certainly post the link in chat to YES. But there are others as well. There's an early career science forum for the Polar Work, APEX, and others. So those are opportunities for networking for early career scientists, but we're also looking to strengthen our networks in some regions as well. But this is a big question. I think the Academy, the WCRP Academy, could also address that as part of our one of our strategic goals going forward.
Okay, the next question was directed to John. The high resolution model for cold regions looks great. Could it be implemented to other regions by changing something in the land surface?
Yes, it's fairly easy to implement in other regions. It takes a DEM and simply vegetation cover right now, so we can establish vegetation height. So that's not too hard. Our intentions are to move it toward global application. We're starting with a test case in the Pyrenees right now in collaboration with the government of Spain. And but it's important outside of the mountains as well, in the northern Great Plains in North America, the steppes in Eurasia, and in the Arctic, Antarctic, and Greenland ice sheets. These wind redistribution processes remain very important.
So maybe one more question.
Okay, the last question I think is geared towards Dr. Uccellini. How does NOAA connect weather, water, and climate in modeling, research funding, and user support in terms of weather, water, and climate products?
So currently we have a climate weather linkage in the sense of the internal parts of our weather models are used for the climate community. We have separate water models, but what we're working towards in the future, and in fact the future is now, we've already implemented a framework for a unified forecast system, and our efforts over the next 3, 4, 5 years is to bring the weather, water, and weather, water, and climate aspects together in a more streamlined fashion, and not only that, make this available on a platform like GitHub, where the research community can download and work with that data. I should also note we're doing the same thing with the space weather community in the sense that we're raising the top of the model to 600 kilometers. So we can account for the influence on the stratosphere from above, number one, and also the wave activity from below that would affect the ionosphere. So we're looking at that terrestrial and space weather concept being unified within this framework as we move forward. Thank you.
If there are no further questions, Amy, may I ask the panelists to address one question that I believe is important for WCRP, and it regards to your experience with dealing with the users of climate information. And that question, I mean, all of the presentations, most of the presentations address the issue of users. It seems to me that users are becoming savvy in terms of the needs, their needs in climate information. And in part, it's in response to the impacts. The impacts are a learning process for many parts of society that they need more climate information to be prepared to resist or to respond to these impacts. My question to you, and particularly to those of you who address the issue of transdisciplinarity, is how far society is becoming more aware of the need of climate information and more recipient in terms of how to address the issue, and if that response of society is actually facilitating closing the gap between science and policy. And this is particularly relevant in light of the Lighthouse activities that WCRP are planning, and to really help WCRP learn from other experiences in how to move to the next decade and enforcing the new program in WCRP. So if you could take just a few minutes to address this issue, it would be very helpful.
I guess I could go first here. As the director of the Weather Service in the United States, we're interacting with the users all the time. With respect to this topic, weather, water, climate linkage, I can use two examples. One is out in California. California is actually supporting a lot, much more research now in this domain space of the subseasonal to seasonal. Driving their water resource management decisions and how our seasonal forecasts affect that, while at the same time now driving towards what's the fire season going to be like that's upcoming. And they want to know that now, because the fire season is actually expanding in time, and it takes a while to get ready for that. The other example is in New York State. They actually supported the development of our hydrological ensemble forecast system linked to our global ensemble forecast system, which is more of the weather model. And we've actually mapped that further out in time, and they actually did a complete evaluation of what their reservoir system and how it should be managed as we move into the future. And they feel pretty strongly that they've got a better management of their water resources in their reservoir system because of that kind of interaction. Both of those examples, they actually put money from the states into the development of the types of model and post-processing that connects to their needs. Something that I really haven't seen much. And the governor associations, especially in the western third of the U.S., has been wholeheartedly supporting these activities as well as listing the kinds of uses they want to see. So, this is something that's becoming much more important in the way we operate in the Weather Service across the board, and we're seeing it in this domain space.
Roberto, I can make a quick comment. I think when we are in our organization, we work across the Americas, and so we keep in mind that capacity, the country level capacities vary widely when we have small nations, small island states through some very large countries in the region. And so that's important to think about. And from what I've seen through some recent work in the Caribbean, I'll highlight the role, the leadership of some of the regional organizations and how that has served as a model. For example, the partnerships between CIMH and CARFA, bringing together climate and health sectors at a regional level, then serves as a model and a leadership model for the national level engagements. So we've seen that, I think, is an important lesson learned. The other thing that I've seen is that in some of the smaller countries, the health sectors, for example, where we work, don't have a mandate to work on climate and health. So without having that mandate, then there is no clear pathway to allocate resources or people or a joint work plan with the climate sector. And so that's something that needs to be thought about. And I know that colleagues at NIH and others on this call are thinking a lot about implementation science and how we can, take the science. We've developed these fantastic, epidemic forecast models, but now how we actually put that in practice is a science unto itself. And certainly transdisciplinary science and implementation science, I think, is the leading edge and where we need to be thinking to make a meaningful impact.
I can also just add a very short comment. I think the ICE course is very powerful to visualize how climate can change on a longer time scale, and especially can see the capacity of the climate system to have abrupt changes in the future. And first of all, it's interesting to see if you can run climate models on the paleo timescale to simulate these abrupt changes, because the tuning of the climate models in our instrumental period is too short to catch, and the climate models might not have the mechanism in them. So in that way, it becomes important.
Yeah. We started working with we had about 200 users at the proposal stage, and spent the first 4 months of Global Water Futures working with them to develop the scientific questions that we could ask and attempt to answer that would be relevant to their concerns. From an assessment of the user needs, we then opened a call for proposals and were able to fund 12 projects that address these. These projects were expected to go out and raise money. And so in our case, the original budget of Global Water Futures has been tripled by user contributions, which has expanded our activities tremendously, but it also keeps us very focused on the user needs. We have that we complement that with a core modeling, observational, data management, and KM group that is more removed from the users, that's producing some of the hard science and modeling capabilities and decision support systems that they need. And then we have a level of projects that are more purely science-based that again feed into the system. So we have some projects that are right at the mind face with the users all the time, others that are more removed. And then we found that even this failed with our Indigenous communities. And so we had to slow down, sit down, and develop a completely new strategy to work with the Indigenous communities in Canada. And that's become very successful. And the latest engagement that we've had across the country has led to the federal government announcing a Canada Water Agency, which is the first big innovation in water governance and science in the country in 50 years. So we're very excited about that. And that will lead towards eventually some kind of a national flood and drought forecasting capacity, something we lack.
Thank you. Thank you all.
I'm afraid we have to wrap up this session, I suspect. Helen, is that correct?
I think we will, unfortunately. And yes, so unless there's something, one of the speakers, I'll give the right to, if there's something else they'd like to add. I think it was an important question, Roberto. Thanks for asking it. And I'm taking your place here, Detlef, but I just wanted to reflect how much we can learn from the experience that John and Anna and Dote and Louis have shared with us today. And I'm going to say this in my last few slides, but we're keen for today to be the beginning, not the end of the conversation with you all. And maybe we can follow this forum up with something more focused where we can draw on your expertise and insights. So Detlef, are you okay if we move to the final session? Did you want
yes,
to add
I
some more
suggest
for
we
now?
do so, but before we do so, let's actually thank again our four speakers. These were great contributions to the session, and we apologize that is so short, but as Helen said, to some extent, this is the beginning, and so stay tuned for more.
Thank you, and I do apologise for my bad timekeeping, but I have to say that all of those talks, including the 5-minute interventions from our speakers in session 4, were really fascinating, and I think had so much rich content for us to pick up on that I hope you'll all agree that it was worth the extra time. So I'm now going to wrap up. I appreciate I've already gone over time for you, and you've all got other things to get on with. So I just wanted to finish this session. We will go to the polls in a couple of minutes. Just to Narelle will share some of the results out of the polls, but just to wrap up the whole forum. And I've just got my computer doesn't want to talk to me. Sorry. Here we go. Yes, I guess this is really about encouraging you to keep engaged with us, and we'll keep linked with you. We really do want to involve you as we shape our WCRP. So your input to our activities that you've heard about, there are ways that you can keep engaged with us, and we just really encourage you to do that, whether it's providing suggestions and feedback, or several times you've heard us say, if you want to join this, let us know. So we do encourage that. I also just wanted to make the point, and I know that Detlef wants to say this very sincerely as well, that we are extremely grateful to the support that we've had across our sponsors, across the nations and our national agencies who've supported us so far, and we're really keen for you to continue working with us on our journey. Whether that's to be coordinating and delivering the science that's important to you, or whether that's about co-designing and co-producing where it's appropriate climate information. And I think we got an insight into some of the expertise on how to do that we in session 4. So yeah, this wrap-up session is really just to encourage you to keep in touch with us. In particular for our sponsors and our national agencies, I guess this is repeating what we've said really, but we do stand ready to support you in your needs, and that can be learning more about some of the research frontiers. Louis Uccellini's Precipitation Grand Challenge, there's a really nice example of a research frontier that's critically important for the US nation and probably broader, and how we can direct our expertise towards innovation. The other thing that's not on this slide that I really wanted to pick up on is this is across the whole, today is all about across the whole North American region. So are there some things that we're seeing being done in the individual nations that the WCRP could play a role in lifting to be a more coordinated, more coordination across the region that would benefit other nations in the region as well. So we're keen to have those conversations with you. What that might look like, Louis Uccellini already hinted at this. We are very keen to have some follow-up forums, and these would become more focused than this broader discussion today. So for example, a forum on the precipitation prediction grand challenge or other aspects. So we're keen to hear from you what would work with you. And we've not talked much today about engaging with our early to mid-career researchers, but it is a key part of our strategy. And if there's more we can do there, we're keen to hear from you as well. So if you want to get in touch with us, here's how you can. And while I've got that slide up, I'll just, we will go to Narelle to get the final survey results. So Narelle can be getting ready, but Detlef, is there anything that you would like to add by way of this last slide, and particularly keeping the conversation going with our stakeholders across the scientists and agencies?
This definitely is a very important part. This is a beginning. We do want to actually do this more focused in the future. We definitely, as a WCRP, we want to be in a dialogue with the community, but that community does in fact include the funding agencies, because whatever WCRP wants to do, of course, can only be done on a national level with the national communities, with the national funding support. And so partly this is really also our goal to inform about the upcoming WCRP related research and the importance of it also for the individual nations, because we believe that whenever WCRP can have a success, it will actually benefit the individual nations, and that's why we want to have this dialogue. Now, before we actually come to a close, and I guess we have to soon come to a close, what I really would like to also thank Helen and the entire team for setting up this individual one. There are many around the world of these research fora, and definitely we experienced another great event tonight for the North Americas here. The next one will be Europe, I suspect, and then it goes back into South America, Africa, and so forth. So this is really a great exercise, a great experience also for me tonight to actually see this big interest, to in fact see the questions and the outcome of these questionnaires. They will in fact enlighten us for a while, and we will basically take this and feed it into our process. Thank you.
Yeah, thanks, Detlef. The next one actually is in 2 weeks' time for Southeast Asia and then Europe. And we're learning as we're doing. The big lesson is that we never keep to time. But thank you to the audience for helping us learn how to do this better as well. So now, without any further ado, I need to stop sharing so that we can look at the poll results.
So I'll just say that this is what you were hoping to learn about WCRP today, but did not. Yep. So we've got some answers here that we can go over, some really interesting ones.
Yeah. And these, and just I've got the mute button off, so I can just say while I'm looking at these that some of these points about how we can better engage with the other nations in the region, especially Mexico, Central America, the small island states, we recognize the need to do that. And this is why I was delighted that Anna from IAI was willing to be part of this forum, because maybe we can work with partners in the region. And we do have WCRP representatives from some of those nations as well. And we can really think about how we might do some more for those regions. So yes, that's a very common. And hoping to learn more about the state of the science. So maybe we need to think about how we can offer more webinars on that. So thanks, that's an interesting feedback as well. What other ones have we got, Narelle?
So this one's more about the key areas where WCRP could help to make a difference in the climate research of this region.
Yeah. Yes, so this is the coordination. Yeah, I think that's a really important feedback to us, and hearing what's happening from John and from Louis and from Dorte and from Anna just makes me think what more we might do. And what next? Okay.
So this is just key areas for future research forums.
Yep.
In the region.
So it's interesting for us to just reflect on these, and we'll take them away and distill them into some coherent themes, but I can see some already emerging. Yeah, so there's some interesting ideas coming up here. And I think Narelle also asked if you've got ideas for what a future forum could do, please do enter them into Slido. We'll capture all this Slido information.
It looks like we need to adopt the precipitation prediction grand challenge. I'm not sure if we're allowed to do that.
Well, that's some good feedback to the leadership of the WCRP and for to discuss with our core projects and Lighthouses. And Detlef, if you want to add anything, please do jump in.
Well, actually, I'm reading this, and we all have different hats, but of course, I think these are all also very great suggestions for the upcoming conference, which of course is for the next generation, for the climate scientists. And many of these topics we might in fact pick up also at that conference, which is not too far ahead anymore, and make it actually a topic there. Yep,
that's a good point. Okay, we probably should keep moving with it. I can't remember how many questions that was it. Thank you, Narelle. And we're losing audience, so I will now absolutely finally wrap up by saying a huge thank you to you all for joining. My apologies again for my poor timekeeping. I thought it was really enjoyed the talks, and a big thank you to all of our speakers and to the people who chaired, Roberto and Detlef. Thank you to your input and to everyone who participated. I'll let you get on with your day. Have a good day, and we will keep in touch. That's the other thing. We will follow up after this with all of our registrants with some further information and hopefully a short evaluation. If you don't want to be contacted anymore, do just let us know. You can unsubscribe from that, but we will be following up with you. So thanks everybody for your time today. I really appreciate it, and I hope you all have a good day.
Thank you.
Thank you.
Bye-bye.
Goodbye.
Yep, thank you. Thank you.